And so we already have our next speaker with us. It's Lars Francke. He's the CTO of Stackable, talking about Marispace-X connecting the dots. And I'm just trying to find you. There you are. Thanks for joining us today, and thanks for spending the next 15 to 20 minutes with us.
Thank you. Okay, does this work already? Yeah. Is it time to start already, or another 2 minutes or so?
Okay, if you need another minute.
No, I'm good. I'll just give everyone the chance to reorganize, come in and find out. All right. Yeah, I'll just get started. 1 minute ahead of time, I believe. We'll see. Welcome everyone. My name is Lars Francke, and I work for, actually founded a company called Stackable, but this talk is not about my company or me. 2 colleagues were supposed to give this talk, and both of them canceled on me. So, we are working as part of the Marispace-X consortium, and I'll explain what that is in a second. I only have 15 minutes, so I won't go into detail, but I'm obviously available for questions. And usually around this time I would do the joke of, like, I'm the only one standing between you and lunch, but we don't actually have any lunch breaks, so you're stuck talks all day long. So what is Marispace-X? In May of last year, there was a funding competition by the Ministry of Economic Affairs and Energy, BMWI. It got renamed. It's now BMWK, I believe, with Klimaschutz in there as well. And 11 projects were selected at the end. So 130 project applications from the industry, science, and public sector were submitted. And 11 projects were funded. It was supposed to be 16 or so in 2 rounds, 11 in 2021 and another 5 in 2022, but the second part got scrapped for, we've got a different government, you know how it is. The start of this project was a bit delayed because we got what's it in English? I don't know, the funding announcement only in December, end of December, and it was supposed to start in the beginning of January this year. And yeah, you know how some of these science organizations and universities work. They only start looking for people when they actually have the money in hand. So project start was 1st of January 2022, but that's not that's a bit of a lie. It doesn't really matter, but yeah. And what is Marispace? We got, and I show the partners in a bit, we have a total funding volume of 15 million euros, and it is therefore a lot of disclaimers here. As you see, the largest maritime digitization project with an industrial focus in Europe, and that's pretty nice, and we're really happy that we got selected, or our project got selected there. So who are we, and what are we doing? So this project is a partnership, or has lots of partners and associated partners. And at the top you can see the actual, most of the funded partners. You get Ionos, 1&1 as infrastructure partner, Stackable, where I'm working. We've got Fraunhofer, North IO, True Ocean, Universität Rostock, and so on. And so those are the partners. We did the hard work of submitting the funding proposal, and those of you who have ever done this know this is a lot of pain. And then we have a lot of project partners as well. So we've got Siemens Gamesa. I'm not sure if these mean anything to you, and I'm not going to explain every one of these logos, I promise. And they are one of the world's largest wind turbine manufacturers. We've got So I lived in Denmark and I speak a bit of Danish. I think it should be pronounced Ørsted or something, Ørsted. And they are a Danish energy company. They used to be called Dong Energy. And they are the world's largest offshore wind developer by installed capacity. So there's no company that has more offshore wind power installed than Ørsted. And then we've got a few other little known companies Microsoft is like a technology company from the US. You might have heard of them. Okay, no, okay. It was my bad attempt. And then we've got ThyssenKrupp, then a few other companies. Tough crowd here, man. And we've got the Bundesamt für Seeschifffahrt und Ozeanographie. So we've got partners from all over the spectrum. Science, industry, and yeah, that works quite nicely. Here's a few more. I have to admit, I didn't know all of these before we started either. Schleswig-Holstein is on board. I'll explain why and for what in a second or in a minute. And yeah, those of you who have worked in a big funded project before know that it can be tough to organize all of this and to get all of them under one hood. So project start was 1st of January. The first time we will meet is next week. So everything has happened virtually so far, but I'm looking forward to this. So I asked, but we weren't able to move the Bitkom Summit just for us. I know. Yeah. So and as I mentioned, one of our problems in the funding project was the really delayed. I don't know what the term is like. The Zusage for the funding. So that's why a lot of these universities and so on only started looking for people beginning of this year. And as you know, it's not easy to find qualified people. Okay, I've talked a lot about us and so on, but you have no idea what we're actually doing. So we are doing something with maritime stuff, as I've mentioned. And the goal is to digitize or help digitize the blue economy. Blue economy is everything to do with maritime things, like the oceans, sea, and so on. Everything that's got somehow related to maritime data, maritime projects, ecological business, science projects, and so on. And the blue economy is typically not very digital. It's everyone says this about their own industry, or not lots of you, but here it is really the case. And the project, the Marispace-X project, is a business-driven project. So we are not focused on science, but this is focused on developing business solutions for business problems, which is one way to approach this. I'm not saying it's the only one. And we are working with science partners, but this is one. And this is why we chose 4 use cases to work on and to develop practical solutions for. And this is also why we have all those partners on board, because those partners help us stay on track. They help us figure out what's actually a problem, what's something that we can solve, and so on. And the first use case is, and I like this term, and I think this talk got chosen just because of this name, Internet of Underwater Things. It's just a fabulous name. It's not just IoT, it's IOUT, and it's more or less the same, but a fancier name. But there are some hard things when you work underwater or close to the surface of the water. And the Fraunhofer IGD, IGD is Institut für Geographische Datenverarbeitung. That's a very German name. And they got funding as well from the government to develop an ocean technology campus off Rostock's coast. So underwater, they are building like an underground campus of autonomous vehicles, robots that move underwater, that can stay underwater, underwater stations, and all that kind of stuff. And that's a test bed to see how this can work. This is not like for these future scenarios of people living under the water. This is just to how can we do science? How can we do things underwater? And it turns out that's pretty hard. Sensors often don't work properly underwater. Things like and I'm not a scientist, but even I know that radar doesn't work well underwater, and that's good because otherwise we also wouldn't have all these nice movies with the suspension waiting for the pings and the submarines and so on. But radar doesn't work underwater. We've got sonar underwater. We've got thus the trouble of how to communicate. This is really an edge problem. I mean, it doesn't get much more edgy than this. You're like thousands of meters under the sea, and how do you transmit data? You can there's underwater modems, and they can transmit like 40 bits a second and those kind of things, and it's hugely expensive to do so. So there's no way lots of this data can be sent to the cloud because we don't see the cloud from underwater. There's no way we can access it. And so we need to find some solutions there. And that has been a problem in the past, and we are trying to build data spaces and services to help people do this, to help people with the processing of the data, because those guys are smart, and girls, I'm sorry. They're very smart. They know how to do the science bits, but they often lack the knowledge of how to process the data, how to store the data, how to compress it, how to make sure that it arrives at the final location in time, and then it can be shared. And yeah, other things are also very hard underwater, things like repairing stuff, building stuff, and so on. So there's lots of things that need to be done underwater, and we are trying to build technology that helps those guys, basically frameworks to do this and to share the data and move the data around. So that's the first use case, and we're working with the Fraunhofer Institute on what we can do for them. And yeah, so that's the first use case. The second one obviously gained a lot of attention this year due to unfortunate circumstances, and that's offshore wind. We believe that offshore wind is a key component to achieve like net zero and to the new Green Deal and the EU and so on. And I don't know if you've ever been to an offshore wind park. They are humongous. They are like really, really huge. And those turbines are huge, but also those cables. This is actually a picture I've taken here in Berlin at 50 hertz. They are the transmission operator, so they operate the power lines here. This is a cable connecting the offshore wind project Westlich Adlergrund to somewhere close to Rügen, or to Lubmin. So the wind park is close to Rügen, and they connect this to Lubmin. And this is a cable like this size. It's huge, and you can't really see it, but there's two fiber cables in there as well, because those offshore, it's really, really hard to see. They are like, this is obviously the stuff where power goes through, and then you've got these little things where you've got the fiber cables, and these offshore wind parks generate a shit ton of data as well, and all of this needs to be transferred, it needs to be acted upon, and it needs to be stored for the lifetime of these projects, and the lifetime is 25 to 40 years, and you need to store this, process it, and make sure everything works. Yeah, so that's another sensor. So is the clock correct here? Do I only have 3 minutes left? Okay, I was just sorry. Otherwise, I would have spoken very fast now. Another use case, again, this might not be as prominent, is munition in the sea. I come from Schleswig-Holstein, so this is something that's in the news where I live every once in a while. This actually happened up until the 70s. People usually think most of the munition in the sea comes from the First and Second World War, but that's not true. Most of the munition that got dumped in the Baltic and North Sea happened in the 60s, 50s, 60s, 70s, because we just didn't know where to store this old stuff, and we didn't think about the environment as much as we do now, and so we just dump it in the sea. And that obviously is like, today, it sounds like a bad idea, and it is a bad idea. So it contains 1.6 million tons of munition, the waters around Germany. That's, a colleague of mine said, this is like a train of 2,500 kilometers in length from Paris to Moscow, and that's a lot, and we need to get it out because it leaks chemicals, it leaks stuff, and so on, and it can explode, obviously. And this is a huge problem for the ecology, for animals, plants living there, but it's also a problem if you want to build new offshore wind parks, because, like, let's just drill into the ground. Well, shit, let's not. So we need to clean it up first. And that's another thing, and for this, the seafloor is scanned, and you get point cloud data, and that's really, really hard to analyze. I mean, you have the problem, depending on where you live, under your homes. When you build something, you also need to look at satellite pictures, was there a bomb, and so on. And now imagine the same thing on the on the seabed. So this is really, really hard. Point cloud data is really hard to analyze. It's 3D, there's uncertainty in the coordinates and so on. And again, the project aims to, and this is something that there's a prototype up already, that processes this point cloud data and tries to identify ammunition in the sea. And this is also about like identity and trust. This is where Gaia-X comes in, because like we work together with the military, Kampfmittelräumdienst, I really don't know the English term of that one, Kampfmittelräumdienst and private companies cleaning up this stuff. And the next thing is biological climate protection. I'm sorry for the formatting error here, it doesn't really matter. So we've got woods, and everyone agrees that having like a tree is good because it captures CO2, but there's also things like seagrass. And 1 hectare of seagrass stores as much CO2 as 15 hectares of rainforest. So there's projects underway to actually plant seagrass woods under the sea. But again, you don't want to do this just anywhere, because danger is you just introduce invasive species again, or you do something bad not on purpose, and you need to identify the areas where you can do this. And again, this is where the technology that we're building can come in to identify places where you can plant these forests, where you can do this. Like you need to find the right and the correct places, and that's not always trivial. As you can see here, this is just a fabulous picture. You can see it live on GBIF.org, GBIF.org. This is an organization collecting biodiversity information data. And every one of these points is something where someone collected some information about a species. It can be an animal, a plant, or something. And as you can see, we don't know a lot about our oceans. This doesn't mean there's nothing. There's also a category of absence data, which we're starting to collect, where we trying to collect things that we don't know. So we looked, but we didn't find a tiger in the ocean. This is information that needs to be encoded as well. And this is the map that we need to fill in. We need to basically get rid of the blue spots. You can see just these lines between Europe and North America. Those are commercial freight liners that have like a trailing thing, and they collect for science. They collect species and so on. So I need to speed up a bit, I believe. We'll see. So we have the same problem as lots of industries, and everyone thinks they are special, but we really are. And this is hard. I mean, because, as I said, we don't have internet in most places. We need to collect the data. Autonomous vehicles, some are tethered to the seabed for like a year or two, and then they automatically release their tether and they float to the top. They submit their data for a day, and then they run out of battery. And we need to capture that data, and it's very valuable data. But yeah, there's no Google Cloud on the ocean yet, or Azure. Sorry, Microsoft is a partner. Yeah, there's no Azure Cloud on the ocean yet. So we need to capture it somehow. We need to work on this, and this is what we're doing. Yeah, that's just so. There's some common themes in the 4 use cases I've mentioned. There's lots of data, but lots of this is very hard to gather. The communication is very, very limited. There's also, as in every industry, missing data format standards, or there's too many. Either one you can pick. And the processing is very complex. Geodata is very hard to process compared to like business data, like CSV files full of like transactions from a bank. It's trivial compared to geodata. So what is it we're building? And I know I've talked a lot about things, but this is what we're actually doing. We are trying to build a data space. A data space where maritime projects, companies, and so on can share data. They can collect data, they can analyze data, they can also sell data and so on. For those of you with the Gaia-X background, database connector stuff and so on, you can have like a data sharing economy, and then services on top, because lots of these organizations often don't have the knowledge on how to process data, how to do big data analysis and so on, and we try to make this easier. So this is where we at Stackable come in. We are trying to build like open source processing platforms and so on for them. And yeah, so that you can then collect the data once, help with processing the geodata, and then get the data from the edge to the fog, which can be a ship, for example, or some station at land, and then to the cloud. So yeah, I think most of this I already mentioned, the value propositions and applications, and who the target groups are. So we are trying to contribute to the EU goals of digital sovereignty and sustainability. I think this goes well to the things that I've mentioned, the use cases. We are trying to accelerate and grow the digitization of the blue economy. I also mentioned this before, so this is a reiteration of what I mentioned. And also, obviously, trying to create some jobs, if possible. And the tangible benefits for the user of the things that we're building is also, as I mentioned already, you don't have to do everything yourself. You can benefit from what we've done. You can work with other industries together. You can bundle data. You can bundle services. You can share your data, and there's no vendor lock-in. So we are trying to build something completely open source. And economies of scale using cloud technologies and so on. I think this goes without saying. So I have a few slides about Gaia-X, but I think it's time to finish up now. Those were my backup slides, so I'm right on time. If you've got any questions, let me know. Thank you for listening in. I know this was very little practical information about what we're actually doing, but I hope it was still interesting to hear about things happening underwater. And if you've got any questions, let me know.
Yeah, Lars, thank you very much for joining us today and for quite spontaneously taking over this thing. I guess it wasn't just chosen for the fancy title, but really for some insight. So I hope you all enjoyed it as much as I did. We unfortunately don't have time for questions on stage, but I'm sure you'll stick around. So if anyone wants to know more or get all the information from the Gaia-X backup slides, I'm sure you'll cover that.